Hi, everyone. It's Judy Warner. Welcome back to this week's Ecosystem Podcast. I'm encouraged and excited to introduce you to CEO, entrepreneur, and Silicon Valley startup, Duncan Haldane of JITX. He and two of his Berkeley alums started this company with a grand vision of disrupting hardware development through software. It takes all the intelligence, the wisdom of top engineers and actually bakes it into software code and gives you so much more flexibility than you've had in the past. No more bad auto routers. I think you're really going to enjoy this conversation, and be sure you go check out the show notes and check out JITX. I'm really excited about this startup, and I hope you will be too. And also remember to go sign up for the ecosystem. I've got a newsletter coming up and I don't want you to miss it at thedoubleecosystem.com. Hi, Duncan. Thanks so much for joining me today. I'm really looking forward to our conversation and learning more about JITX.
Hi, Judy. Thank you so much for having me on.
Well, before we get off and going deep in the weeds, can you tell our audience a little bit about your educational and professional background?
Sure. So my most recent education was I was a robotics PhD student at the University of California, Berkeley. And then as professionally there, I was doing paid research, so building robotic platforms to test new ideas about how we can take inspiration from nature. So why does this monkey jump so well? That was a question I asked, and what can we learn about that to make better jumping robots?
Right.
From there, I transitioned right into JITX. So I met my co-founders at Berkeley, and we started work right away.
So tell us about the relationships with your founders and what led you to go from jumping monkeys to JITX. Well, go ahead and answer that question, but then we have to fill in our listeners what JITX actually does. But go ahead.
Sure. Yeah. So to set the context, JITX is a way to design circuit boards by writing code instead of taking the usual graphical approach where you're drawing a schematic and Googling for parts and building spreadsheets. So it's just, how do we take hardware engineering and put it more into a code discipline similar to designing a chip or programming an FPGA? So that's the high level. And I got there based on my experience as a roboticist. So robots are complicated to design, and they're really hard to design if you don't want to be like broken all the time. And so I found that that was one of the hardest parts of my job, right? Like I could do the science, I could study nature and write down this little sketch of an idea on a napkin. And then I spent all my time as a hardware engineer to build this robot so it's robust enough so I can do repeatable scientific experiments, which is a pretty high bar. And so we invented new way to design things, like new optimization methods to search for robotic mechanisms. And I found that really rewarding. And then I took a class from someone who's now my co-founder in the architecture department. So I was so desperate to automate my hardware engineering work that I was like, I got to find people automating hardware. And this guy was teaching a class he's computer science, but he was teaching in the architecture department. And architecture is in buildings, not as in computer architecture.
Right.
And it was about automated design. And how do you take a hardware engineering process, no matter what, really, and turn it into software so that new designs, you basically just change some parameters and hit run, and you get everything, all of your manufacturing files out the other side. And he'd been doing this for 20 years at that point at MIT, at other lab. And so that's Jonathan Bachrach, who was a assistant professor at the time, but is now one of the co-founders. And then Patrick, our other co-founder, was his student at the time. And we all just liked working together. We said automating hardware engineering is probably the most impact we could ever have on the world.
Yeah.
We really liked working with each other, so that we decided to spin out JITX.
Okay, so I've been around hardware engineers and board designers for all of my adult life. And they always say, I've never met an auto router that doesn't suck. Or how can we do such great rendering, say, in building buildings or building semiconductors, and then we're still dragging traces around.
Yeah.
Now 3D, when 3D came, that was a massive innovation. So I think I want to start with that. Why
right.
is it stayed the way it is? in your mind, and how do you imagine solving that problem?
That's a really great question. So I think, why is it the way it is? I think you can look at the history of the industry, right? So 1984, chips got pretty complicated, and they found that, hey, you could design more complicated circuits if you put down the schematic drawing tools and write code instead. And Synopsys is like, we're going to start designing your chip for you. We have this thing called synthesis, and synthesis gives you correctness and optimization. And that's just like, when you get those things, you can design better hardware. But that didn't happen for circuit boards at the time. Even though I think the companies started at the time, you had like Auto Tracks back then with NX, right? And I think that through a series of acquisitions is now in Altium, right? It was like Proton and it was Altium.
Yeah.
But boards in the 80s were pretty simple, relatively simple, right? And people did heroics in the 80s to design circuit boards and Mac computers that actually worked. But it doesn't look like what we have today, right? Mm-mm. So 2008, things got weird. You have like the iPhone, right? So now it's not this kind of big square thing. It's super compact, and it has to last a really long time on the battery, and it's got 3 radios. And that, it doesn't look like the same design, but you're still using the same tools because all the tool companies grew up back then. They figured out the product that was useful. It worked for the technology of the time, and then it got pretty well locked in. Mm-hmm. But today, things are much more complicated. And the labor is different, and the way we design stuff is different. So, but that's why it is the way it is today. One of the big reasons.
I see.
But I think that's a little less interesting than talking about why autorouters suck so much.
Yeah, so let's talk about that.
So I think, people definitely use autorouters. And I'll tell you today, some very large hardware designers are making their tool choices based on how good the autorouter is. So because there's a massive labor shortage, the people that laid out their boards are retiring and they're not being replaced. So there's a need for automation. Mm-hmm. But I think the one reason autorouters are bad is like, there's 2, I think, primary ones. One, they don't have enough information to do a good job, right? They don't, unless you spend a lot of time typing in constraints, they don't know what your design is or what you're trying to do or about the new material you're using or what a good design even looks like. What do they track? Is it connected?
Right.
How many vias did I use? I was like, that's a start, but it's not like, there's a reason people route their sensitive traces by hand and artistically instead of throwing it to the autorouter. Right. So there's this like huge bottleneck in just entering data that makes autorouters work. That's so high that it's not productive anymore. Right.
That makes perfect sense to me.
That's a big one. And another one is, I think the way routers work does not fit with a realistic place and route flow. Because imagine that an autorouter worked perfectly. What do? It's like, I will drag every component I have to its perfect position on the board. And I don't need to swap any pins. And I don't need to move anything. I'm just going to exactly position everything and then hit route. And then it's going to do the traces. Mm-hmm. And nobody designs that way. Yeah. Right? It's like 90% of routing is placement. Right. So I think to do a good job with an autorouter, you have to solve the information problem, so you actually know what you're doing. And then you have to like really embrace the human as part of the autorouter loop, rather than like the autorouter is a piece of software that you run.
And so that's really, like, again, with looking at a model, like with a Synopsys or whatever, and you saw this can be solved with code. So we're going to talk about a few different things around that. But my first question is, on the back of what you just said about autorouters, how, once you finish JITX, all of the development, all the vision that you all have as co-owners, what is that experience going to be like? What do you imagine will be the design, or how will it perform for a person that is taking that on?
Right. So when we accomplish what we set out to build, what is the impact for the person using that software? What are we delivering for the designer? Right. The biggest thing, I think I'll know success when, like, the vast majority of designers can design better hardware with JITX than without it. Like that's the bar for success in my mind, right? It should be a tool for helping people be more ambitious, right? To have, like, because hardware is so risky right now because there's no time anymore to make mistakes. So one thing we do is like scrub designs automatically for mistakes. So you take a schematic review and you automate it and you run it on every single time you run your code. So it catches the issues that you'd only catch later by having an expert read your schematics. You try to take some of the risk out of that design process so users can focus on exploring. So people can focus on optimization, so they can try out new ideas, so that evaluating that next generation radar chip is something you can do today instead of like the 8th thing on your backlog once you clear all of this work that's on your plate because the rocket needs to go or the car needs to drive. Like there's so much pressure put on designers today. What I really want. Yeah.
I heard a bit of that earlier in our conversation when you said robotics is so much fun, and then I had to make hardware. Right? It's like you go in. A lot of engineers I've known are passionate about engineering and making engineering, doing those things, and then they get caught up with schematics and component shortages and things going out of stock and somebody waiting to review the design, and you spend a vast majority of your time doing that. Do you think JITX will be able to in some way free up the engineer to do actual engineering?
Yeah, I mean, and I don't want to knock that work. That is engineering. That's a human experience of engineering.
It is.
But yeah, that we're attacking that today right off the bat. Like, we want, the first goal is like just make people really productive, right? And when you look at like what does it take to move fast, it's like, well, you got to create designs quickly that are free from errors, and that's our North Star, is just like the fastest way to make a board. And to make a board, there is a human engineering organization around it, and interacting with that is also engineering, right? It's not maybe their favorite part of their job, but it's hard, and it's not something people can just kind of walk into, right? And yeah, so we do things like, all right, here's your power regulator circuit. Now you can make it parametric. So you just say what you want the startup time to be and the output voltage to be. And then the calculations that are in the spreadsheet, that's just code. And you run it and it's going to find your passive values. And then, it's going to go source from your preferred inventories, like which exact parts to use. And then it's going to put those in the design and run a schematic review. And that's what it takes to like productively automate something. Because if you just do part of it, it's just like, well, here's your circuit design, but you can't buy the parts and I don't know if it's right. Like that's not productive.
Yeah, I was just talking to I just did a podcast with someone from Keysight, and he said hope cannot be part of the design process.
Oh man.
Right?
But it's always there. Right?
I know. It's like I think I got it mostly right.
Yeah. Or it's like, yeah, I gave my expert engineers this 200 item checklist and I asked them to read these 80 pages of schematic sheets and find all the issues. And they said they did that thing, and it's definitely better than having them not check it. But that's not a thing that humans enjoy doing or are especially good at. Like, as a super senior expert, I don't want to spend my time reading all the schematics or working on one project at a time. Like, you find this industry is driven by those people, by the gurus. And sometimes they have a capital G when they introduce themselves in guru. But they still work on one project at a time.
Right.
Right. And some of them are kind of sick of that.
Most that I talk to are definitely sick of it. So how far along are you with JITX right now and realizing some of those North Star and things that you're aspiring to as a company and a tool?
Yeah. So we launched general availability September of last year. And we have now just... And when we launched at the time, it was a sort of a partially automated tool. You do your high-level requirements in code all the way through component selection and design checks, so you actually know that your schematic is going to work. And then just recently, we've launched our routing tool. So now this is like another way to optimize your design. So it has this new capability to help optimize, which is you can do your pin swaps interactively, so you don't have to like read your PDF and then look at your layout and then like figure out where in your schematic you can change the pins to make things more routable. And so, yeah, we've just shipped that as it just feels so good. So like the part where it's like, it does your schematic and then, you export over to Altium and it finish your layout. And that was fine. It was productive, but it didn't have like that magic feeling. But now when we bring in the routing algorithms that are helping optimize the entire design, I'm really happy with how it feels. Honestly, it's hard to characterize.
It's like your firstborn child, or maybe your second. I don't know, something like that. It's very satisfying. So, Duncan, you mentioned you launched in September. How far along are you in the development and building out the full vision that you and your co-founders have for JITX?
Oh, great question. And full vision might take a while because JITX means just in time everything. So this idea of like software for hardware is not just for circuit boards. And we've got some advanced projects pushing that further already.
Interesting.
But yeah, focusing on the circuit board aspect. When we launched in September, it was a partially automated tool. So you go from like requirements level input in terms of code, and then the output is like a detailed schematic. It does your supply chain optimization, and it checks it for errors, right? So you know that when you lay the schematic out, you're not going to have any circuit problems. And that was productive, but it wasn't, transformative, right? And so what we launched just recently is a new routing tool to go along with it. And we built this to help people optimize their designs. So the new part about the router is like, it's 2023 and we built a router. Why? Right? Is a good question to ask. And
is it a router that people don't hate? I think that's why.
Yeah. Like to have automatically created routes that are just like a pleasure to interact with is, I think, a brand new experience. And we built it to help people optimize their designs. So it does things like helps you swap connections. When you're, say, fanning out a FPGA or even just a microcontroller, you have some freedom in how you assign the pins to make it more routable. And right now, people got to read the data sheet and then edit the schematic and then look at the router and then like try to coordinate across these like three pieces of things to be able to swap pins and save money by routing on fewer layers or get better signal integrity. And we built a router that lets you just do that in place, so you can solve that pin assignment problem with the router, which is kind of the actual form of the problem. Like, I want a component and I want a process which gets me fewer layers and high signal integrity, and we built like a router to solve that problem. And it just feels different to use. So that's been great. And, we've also had some really great projects with customers so far, kind of working with people across the scale from like small robotics startups to very large enterprises to show that like, yeah, this is the technology can solve some valuable problems.
So what has been the feedback so far and what have you learned along the way?
Ooh, I think you learn a lot at a startup. So here, the feedback is that this is very powerful, right? You get a lot out of the design reuse aspect. The fact that you can take design reusability and move it past kind of copy pasting schematic sheets together, or kind of have like a block utility in your CAD tool, but really being able to meaningfully reuse your engineering work is the highest impact thing. And we're just directly guided from feedback. Like, I spent all the time talking to customers and like expert electrical engineers and like figuring out where the problems are. And the other thing I've seen is that this is like increasingly helpful because you're seeing kind of roles kind of starting to merge together. So it used to be that like designers at a large enterprise would like write down an architecture and then hand it to someone else, and they would like, that person would draw the schematic. Then they would hand it to someone else and that person would do the layout. And those threads are coming back together. One, because like systems are more complicated, and when your tool doesn't really help you collaborate, then it makes sense for like one person to do more of that.
Right.
But there's also like, it's harder to hire those experts these days. So the feedback I get is just like more automation. Right? That's
to that point. I heard that I ran into someone, engineer from Northrop Grumman recently, and just, this is anecdotal, I haven't researched it, but he said that they were looking to hire something like 12,000 engineers this year.
Yep.
Like, oh my goodness,
Yeah.
so the shortage of engineering talent, like competent, capable. So I think EDA tools like yours, helping to realize that is going to be, because like you said, we're losing all that tribal knowledge of the
Right.
gurus. And this sounds like a super relevant thing, which is why I wanted to talk to you. So you got the fundamentals down, you got the auto router, you're getting customer feedback and learning along the way. What things are sort of along your roadmap that you're looking forward to, or
Yeah.
after you sort of have this baby weaned, what do you want to tackle next?
So our roadmap looks like continuing to ramp up the complexity of designs you can automate, right? So how fast can you create the design, and how close can you get to designing like a data center board? Because if you talk to large companies, that's where their concerns are, right? You can offer to help them with like, the kind of the lower end or the simpler stuff, but that sort of high complexity area is really the important thing. So yeah, what's coming up next is like, I talked about that router as like a pin assignment optimization tool. So combining into that, we're going to start having advanced VIA types, because a lot of people these days are spending all their time like fanning out chip scale packages with micro vias. Like it's taking a lot of time. And then you still have to do that like pin assignment optimization. Is like, okay, so what vias and what routes and how am I going to fit them to get the best signal integrity and to make this like routable, so I don't need like any layer vias, which you see in some miniaturized devices. That's expensive.
It's expensive, and back drilling and the layer counts are crazy.
Yep. And it's easy to get yourself in a bind, especially if your design and your layout is not especially flexible, right? So the next step is like, take this router and then like turn it up to 11, so you can start searching across materials and stack ups and VIA strategies and figuring out what it takes to realize your design in a miniaturized form factor without, taking 12 months to design it, or without breaking the bank on bad yields and super expensive processes.
Yes. Or spinning it 5 times or whatever that ends up looking like.
Yeah.
Yields
honestly,
are a big problem, right?
That's right. Yeah. And it turns out that automated checking can help a lot with that. If you do it thoroughly and you're trying to fix like a 1% failure rate, you have to make a lot of boards at the factory to find a 1% failure rate, right?
Oh, yeah, you do.
Yeah. But if you just like apply the same knowledge that experts have, like that one guy that knows how to do iPhone stack ups, and apply that to every product, you can do so much better. Right?
That's amazing. So you've talked about software code. Is there any application of like AI here or machine learning? And forgive me if I'm asking softball questions. I'm just not sure, since I'm not explicitly familiar with software, like how that piece might or might not fit in.
Sure. Yeah, and the software side we keep pretty simple. So most of our users have written some scripts in Python or MATLAB to process data on some tests. So one of the main things we got working first is like, we need a simple language that can automate expert electrical engineering. And that was really hard to do, but the language itself came out pretty simple. So you kind of write scripts that it reads like requirements. Like, this design needs an FPGA. It's going to operate in this aerospace environment. I want built-in self-test to work, stuff like that. And then that gets turned into your detailed design. And to do that, we use a lot of AI methods. And those work as solvers, kind of behind the scenes of like, you can just write more powerful code that way. When you say like, I can figure out what resistors to use or what circuits to use to fulfill this goal, then the user gets to operate at a higher level, and the code they write just gets more reuse. So AI, in the classic sense, is to serve that goal. And we also have kind of modern growth of large language models like ChatGPT. Those are, we've tested those. They're pretty lousy at designing circuits, and our customers are professionals. Like, they don't necessarily need the help to design a load switch.
Right.
But instead, there's like a lot of human structured data that they interact with. So you can start building automation into softer things like pulling meaningful things out of data sheets, that kind of thing.
Data sheets. We don't want to go down that road, but can you make the data sheets honest? What do you do about that issue? Because I've talked to a lot of engineers that say they don't really trust the models as is.
That's
unless they're putting
correct.
test coupons on their boards or whatever to measure real world data.
Yeah, as a Northrop engineer explained to me, data sheets are like glossy marketing brochures. And
that's a good way of putting it.
Yeah, to a lesser extent, like a limited liability guarantee. So, your min-max ranges are not going to be representative, but you can't go complain about it later. So,
I had someone from a large semiconductor company when I asked him, he's saying, our data sheets are not good. And I'm like, why? And he goes, we've got lawyers. So that's it. What you're just confirming to me what he said is it's like, you can't sue us later.
Right. So and it's not about the designer, is it?
No.
And some companies do great, and they should be praised for their data sheets because they really invest in it.
Agreed.
But that's one thing I learned when coming to this industry, is that there's actually a huge data problem. And it's kind of stuck in this nasty place where there's no simulation models because very few people simulate. And so there's no simulation models, right? Even though the data's there, like the flows to make it really valuable for the user are kind of broken. So that's something we do a lot. We get data, we enrich it, we make sure it's correct, because now we can use it in this automated way. And my goal for data sheets is I just want to work with the semiconductor company directly, because they have that expert, they have that guru that knows how to get the most. If you want to optimize the load transient of this buck converter, they got a guy, but it's only one guy, and they usually put him on the largest customer for 3 months at a time, because he's a designer like everyone else.
Right.
So my goal is there is no reason that we can't turn that person's work also into code. So this chip maker can help just automate application engineering and say the best of how we know how to implement this chip can be run on every single board, and we don't have to be there to do it. Because the reputation right now is pretty lousy. Customers don't necessarily reach out for help because they're not used to getting a support person. They're used to getting the sales engineer who then maybe can connect you to the guy that designed the package for this complex processor and knows exactly all the tricks to make it fully routable and get good performance. But you can never talk to that person because that doesn't scale, because it's one project at a time. So change that, right?
So you're building that scalability into the code, basically.
That's right. Yeah, and code you just get that for free, right? So code, you just run it and it does the thing and it does a complex thing. The hard thing is get hardware engineering into code. And from there, once it's code, this is a very normal thing.
Yeah. It's something I've been talking about a lot, especially after my tenure at Altium, is there's been this continuing conversation about how software can disrupt hardware development. And different people are coming at it different ways, but what you've done here is very compelling. And I'm really excited to see where you guys go next. What would you say was the greatest obstacles to getting JITX out to users?
Yeah, great question. So our customers are professionals, right? And what they're doing is hard and complicated. And they need productivity tools, which means they're also very busy. Right? Yeah. So I think the biggest challenge is how do you get people into valuable automation quickly? And also help them self-serve into that, which is an even higher bar, because I think most people in the industry are incredibly good at teaching themselves because they had to teach themselves. And the people that could make it in this industry are able to teach themselves. And they don't necessarily want to have a success call with a salesperson, right? They want to be able to say give me the tool, give me the materials. I'm going to figure out how to do this myself.
Right.
And this is a new thing, solving a complex problem. And they have to self champion into it. And that's been tricky. Yeah.
Yeah, I understand what you're saying, and finding those people who will sort of collaborate with you and come along for the journey when they're already so busy. These people are very, very hard to find. And even if they wanted to, usually they're too busy. So I can see why that could be an obstacle. But it sounds like you're making your way through
Yeah,
with the champions that you have. But
that's right. And I think there's actually a lot of those people, like for anyone that's touched an FPGA, for example,
yeah,
they understand that, hey, maybe hardware should be coded because they never go back to using schematics to program an FPGA. But
yeah,
they're busy and it's very time specific. So like they have maybe 3-4 days out of like a 3 to 6 month period. But they're like, I'm going to look up, I'm going to pick my head up from the desk, look around for new tools because I need a new way out of this.
yep.
And you just got to be able to, yeah, make that connection.
Well, that's why we wanted to have you here, so we could spread the word, and hopefully we'll create a way for people to reach out to you if they're interested. In the context of where you are and where you're going, when you look kind of across the industry and the outlook, what are your observations for future trends and sort of where do you see JITX fitting within that roadmap as far as future trends go?
Yeah, so the trends I see in hardware is that, well, it's getting harder, right? We have smaller, faster chips, new manufacturing technologies, and new and continuous goals to like make a more complex system with less time. And that's made things harder because you kind of had previously separate domains like power integrity and signal integrity and materials choice and then like system design. And now those are like merged into one big thing that also includes like thermal simulation. And the tools to address that are still separate, right? You have, if you're going to do that optimization or checking or simulation, there's like an expert that drives a simulation tool and you like send him PowerPoints and he sends you PowerPoints back. And that's a hard way to co-optimize something. So I see that as just a trend that's never going to stop because you just keep getting better products out of it, the better you can do it, but it's challenging. And yeah, I think there's a lot of tailwinds behind the electrical engineering now, right? You got senators going around to chip factories to get their pictures taken. Like that's wild. That has not happened
wild.
before.
Can you believe we made it to front page news in this industry?
The component shortage was in like headline news for months. There's always been a component shortage. It's never been that bad, but like it's very front and center because people realize how important hardware is.
Indeed.
But at the same time, you don't have enough people, right? You can see the graphs of electrical engineers versus computer science students. And I think a large part of that is like, how do you get them attached and excited about the industry? And I'm happy that like, I think code is a great way to do that because in school, they just kind of assume it's already like this before they learn about hardware design tools. It's like, oh, of course I can like script and automate this out. It's 2023.
I know. And then they get here and they're like, what's this 80s tool I'm using? And I'm like, sorry.
or they just bounce before they make it.
And they've been gaming their whole lives, and it's like, what is this? And, for very complex electronics, I'm being obviously tongue in cheek, but young engineers have talked to me about that. Like, what the heck? And I'm like, I know.
And it happens
part of it has been because particularly, in the university, the detachment between the university and industry that's a problem, I think, as an industry we need to solve. And along those lines, are you working at all with universities like Berkeley, like your alma mater, to bring them along this journey with you?
Absolutely. So we engage. We set up a university program recently, and so we're like going to be continuously growing that out. We just provide free access to the technology because like it solves the problem I had like as a grad student at Berkeley, but then this is actually a national problem, and we've got professors that want to use JITX to teach their classes because it's like a much more approachable way to learn about hardware because you can take all the knowledge and put it in code. And to know if your circuit works, you like get the compiler to not have any errors, and that's just like a much more scalable way to learn. So we've had it feels good to get that interest from universities and be able to contribute back to that. And this next generation of engineers is going to be amazing. Like, the students are amazing in what they can do.
Oh, I know. I'm with you. My favorite part at Altium was working with students because they're amazing.
Yeah.
You know, all that gaming and playing with software since they were one,
Right.
you know, or whatever. They are so bright and so capable. So we just got to give them those tools like JITX so they can go crazy. It's wonderful.
Yeah. I hope we can build a better bridge.
I think so. Well, Duncan, I know we're about out of time, but thank you so much. I hope you will come back as you keep improving this tool and share with our audience all the progress you're making. Is there anywhere you'd like our listeners to go besides your website to learn more about JITX or to get a demo? Or what would you recommend for people wanting to learn more about JITX?
So our website, JITX.com, is probably the best way to see the product, maybe get a demo. They're also free to email me directly. I'm always very interested in hearing all sorts of feedback. So they can reach me at d.haldane@jitx.com, and maybe we can put that in the episode description.
We definitely will. Well, again, Duncan, wish you all the luck. It sounds like you're really making some good progress in the area that's long overdue. So thank you so much for coming and sharing your journey with us, and best of luck to you in JITX, and please come back and give us updates.
Yeah. Thank you for having me, Judy. This is a great conversation.
Thank you so much. To our listeners, I will make sure and put those links for you below in the show notes or in the description. So go on over to JITX.com and take a look, or reach out to Duncan if you're one of those people that wants to help them go along the journey with them and help sort of co-develop this tool. I'm sure he'd be thrilled to hear from you. So thank you so much for joining us today on the podcast. I hope you've enjoyed this conversation. We'll see you next week. Until then, remember to always stay connected to the ecosystem.